Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the values for a purely capacitive parallel circuit from the Chapter 17 math handout, problem number 13. So here I'm given my known values from the Chapter 17 math handout. In our previous example of number 9, we were given capacitive reactance, so we had to find capacitance. In this case, we're given capacitance, so we got to find capacitive reactance. I've already copied the formulas we need, and so let's get started. First thing we're going to do is fill in all of our V values because it is a parallel circuit. So formula number 5 shows me that voltage stays the same in parallel. Now that I have those, the first thing I'm actually going to do is find CT, not XCT. So let me change that. This should say CT. Alright, so I'm going to find my CT, and we see here in a parallel circuit, formula number 8, capacitance just adds up. So if I add 2 microfarads, 0.25 microfarads, and 1 microfarad together, I get 1.45 microfarads. Now that I have my CT, I can find all of my XCT values. So again, this is wrong. Let's do this. X. Alright. After I find all of my X's, then I'm going to find all of my I's. Alright. So now that I've found all of my capacitance, I'm going to find all of my capacitive reactance values. So to find my XCT, I'm going to use CT. And let's see, I need my formula. I need my frequency. And if I look on my math handout here, it shows me that my frequency is 1.989 kilohertz. So let's put that on the screen so we'll have that for reference. Alright, so we're going to go 1 over under 2 shift pi times my frequency of 1.989 times 10 to the third times my capacitance 1.45 times 10 to the negative 6. It equals 55.18 ohms. Now to find XC1, I'm going to use C1. So I got to go over here, change this value of 1.45 to 0.2. It equals, and that's 400 ohms, 400.0. Really should be 0.9. I don't know why I didn't round this in the past. Alright. Now we're going to change our C1 value to our C2 value. So we're going to have 0.25 equals 320.07 ohms. And to find our XC3, alright, now I'm going to change this value to 1 microfarad. Gives me 80.02 ohms. Alright, my next step, last step, is to find all of my I values, and all of my I's will not be the same because this is parallel. Current adds up in parallel. So I'm going to use Ohm's law inside of these parentheses. So I'm going to look for ICT by taking 24 volts divided by 55.18 ohms equals engineering 434.94 milliamps. 24 over 400.09 gives me 59.99 milliamps. 24 volts divided by 320.07 equals engineering 109.06 milliamps. punched in the wrong number. Let me change this to 320. Alright, 74.98 milliamps. And we'll do 24 volts divided by 80.02 gives me 299.93 milliamps. And then here's the values you asked for on the assignment on your Canvas page. These are the values you would punch in. Thank you.